Thanks for coming along to the talk. This is our office. I'm going to be running through how we build stuff using large language models. I want to make this as unhypey as possible. So I am not here to sell you a post AGI future in which the engineer will be forever on the scrap heap. But we've just built some pretty cool stuff that I'm pretty happy with, and we built a lot of that in Golang. So that's what I'm here to talk to you about. Cool. So this is some examples. So say your engineering manager or your product manager tells you, oh, we need to build some AI features, right? This quarter, it has to happen as soon as possible. If you cruelly, like I have done, and unfairly pick some of those blog posts, the first example is the first line is always first install Python, pip install this library, right? And Python has got a lot of the mind share in the sort of LLM world, and we just sort of don't believe that there's a reason that has to be the case, right? We build stuff in Golang, and to do that would be a big effort. None of us here are very good at Python, right? So yeah, I'm basically here to say it doesn't have to be true. And then the actual so I've picked one of those market maps that you sometimes see venture capitalists post on LinkedIn, and there's basically a lot going on here, and all of these are different technologies that let you talk to foundation model providers in a whole host of different ways, and they're all sort of different. The nouns mean different things. Sometimes the same noun means different things. It feels sort of the front end world felt when it was React versus Angular. You know, every single week there's some new framework that's better than the previous framework, and the person that created it will get in massive flame wars about it. But basically we've tried a lot of these out. We've looked at a lot of them, and we've not found them to be a super large value add, if we're totally honest. Either they're really simple and a light abstraction layer on top of something that we would rather own, or they're really complicated, very opinionated, and force you to go their way or the highway. And we're not that interested in doing either of these things. As with all things, I'm here to tell you that we've built another framework that we use internally, and that this framework has been really useful for us. So yeah, that's what we're about to do. But the one thing that is I want you to learn from this talk, or take away from this talk, is this is just the Go programming language. So I am here to tell you that the general purpose programming language that you all use and have come to the meeting group for is actually pretty good at general purpose programming. And one of those things that it is good at is building features with LLMs, right? What do you need to do to use an LLM in production? You need to be able to construct an API request, send those API requests, execute some business logic in response to the content of that API request. And this is just very normal, right? This is not something that you need to learn a whole new programming language for. You can just sort of stand on the shoulders of giants, to quote the quote on the side of the £2 coin. Someone else at a foundation lab has already done all the nice machine learning sort of stuff for you, and all you need to do is just consume some API. So what am I going to do today? I'm going to, for the rest of my talk, sort of give you a rundown of what our internal AI library looks like. I'm going to talk about some of the sort of nouns that we have, and then I'm going to sort of hopefully manage to thread through all of them that oh, Go's actually quite good at this stuff, and I hope you come away from this being oh, interesting. So the first thing, and this is where all sort of the AI chat begins, is it starts with a prompt. What is a prompt? This is actually something that's different in different AI libraries, but what our prompt is for us is the start of a conversation. So it could be a single message, it could just be a single API request back and forth, or it could be a thread. But a prompt to us is this is how we start sending some text requests to this foundation model provider. And you can see here that we have in our most basic prompt interface, we have four of these categories. So we have the model, and the model here refers to the foundation model that we're going to be using here, right? So this could be one of OpenAI's models, it could be one of Anthropic's, it could be Google, it could be DeepSeek, right? And then we also, we as opposed to the last talk, we're kind of pro-generics. Our Go code base is written by people that used to write Ruby. It's quite strange. So we love generics, and we use generics all over the shop. So the input and result here could just be strings, when you're talking to ChatGPT, or it could be something more complicated, right? It could be some structured input, it could be like something multimodal. Yeah, so like that input and result here can basically be anything. And then those are constructed into the prompt. And I think there's like an interesting sort of like technical nuance here, which is you can see that we're actually using the OpenAI struct here. And the reason for that is if you've ever used like object storage, like if you've used S3, R2, GCS, you'll have noticed that basically the S3 API won and everything speaks sort of S3. And we've kind of noticed that like, maybe not so much the case, there's actually been a bit of innovation in like what the API structures look like recently, but for a while it was basically every model could support the OpenAI API in some way, or you can write a light converter. So we basically just standardized on that. It's a pretty good API. And then, so like, what does it look like when we call one of these prompts? So like, you can see here, I have a prompt. This prompt is called prompt, is this talk interesting? And there's some like key components that go into if a prompt is like, if a talk is interesting, and that is like the speaker vibes, the audience sentiment, the refreshment quality, and the potential of overrunning. You can see here that I've run this prompt and we get a sentiment back, and if that sentiment is poor, then we'll panic and say, please stop. But you can see here that this is like one of these like prompts that we have that has structured input and structured output. So our like general AI run prompt interface can sort of take this like sort of generic like contract and do this interface for you. We find it super useful to have like a single entry point to running the prompts. It means we can load like a load of our observability up there. We can do any mutations that we need to like perform. So like this is what a call site looks like when we're running a prompt in production. And then like, so what actually goes into that prompt? So we build inputs using, I don't know if anyone has the displeasure of working out that Go has a templating construct. So these are Go templates. It looks like the APL programming language, if anyone's ever used that. There's a mix of curly braces. The place at which those curly braces are placed is very important. And if you get it wrong, it will explode and it's very hard to debug, right? It's very unsafe. But like basically, we didn't want to write our own template thing, like you may as well use the one that you've got. So yeah, this is like how we sort of like render out the struct of a prompt based on the input data that we provide. But when we're building like the template params, the params that we send to a template, we try and keep that as like in the code business logic as possible, right? Like you want to make sure that your Go template is not smart, right? Like that is what you have to avoid, and that's what we try our hardest to avoid, right? We just want to be building the data and turning it into strings in some function, and then we pass that to the template. Cool. So like another construct that we use all the time is the concept of a tool. And if you're not familiar with tools, tools basically are something that a prompt can run on your behalf. So you tell a prompt you tell a prompt, oh, you have the ability to like search for code changes, for example. And in that, you will like provide a contract of what like a code change search input looks like. And the prompt that you run may decide, you may force it to run this on your behalf, and it will give you the parameters from the text input that you've done it. And then you'll run that tool on the prompt's behalf and give it the result, and it can reason about that further down. So you can see here that this actually looks quite a lot like the prompt interface as well, right? Like we have an input and an output result. The one thing that's interesting here is the run function, which is the actual function, like this is where we implement the actual meat of the tool. And we do something kind of interesting with the run function, which is like very Go, which is that all the foundation model providers sort of support JSON schema to some level. Some will like honor a JSON schema that you've provided exactly and return you a response that matches that schema. Others will return you something, will try to match that JSON schema. Some will try to return JSON, and some won't give you any guarantees at all. But we basically, we reflect over the result type that we have here, and we build JSON schema from that, so that when we're providing, when we're running a prompt, we basically use Go to take a struct and turn it into a contract that the foundation model provider honors, without having to sort of write our own JSON schemas for every single tool that we have. And then those tools, they have toolboxes. So the prompt interface that we have can be extended, and that can be a prompt with tools. And if you have a prompt with tools, that prompt has a toolbox, and this basically tells the prompt what tools it has access to. And you provide the tool using this interface, and then you provide some guidance as well, right? So tools, like if a prompt has multiple tools, it can be tool selection is really difficult. And the more tools you give to a prompt, the more it struggles to work out exactly what tools to call and when. So for example, if you have 10 search tools and you're like, oh, I want you to search for the thing that caused this incident, like it has to determine what that thing is up top, right? And like this is so basically you want to reduce the tool surface area as much as you possibly can, right? Because if you give someone an API, like just as a human would, like if you give them 10 routes to do something kind of similar, it'll get confused and it'll call the wrong thing. So we provide guidance here that when we send this to the foundation model provider is included, and it gives the user some gives the model some guidance on how to use this tool and when to use it. And then the final thing that, and like I think the most sort of interesting thing is like something we do regarding like speculation of tool calls. So some of our the way we run prompts all over the shop, right? Some of those are in response to user requests and look kind of like a chat session, like we have in ChatGPT, and some of those occur in the background. So like some background process is like maybe calling a prompt to gain some insight that it'll store further down the line. But when you're basically in a chat interface style thing, we have this problem where if a prompt calls a tool, that's another round trip back and forth to the foundation model provider. And this just becomes incredibly expensive, right? Sometimes these prompts are calling tools that then call prompts, then call tools. Like you can very, very quickly build like a massive network of tool calls that all interdepend on each other. And every single one of those hops is like another like session, like generation. Like it's basically, there's a 3-second overhead like at minimum here. And like obviously we would prefer to have quality responses over fast responses most of the time, but sometimes the speed of that response is so bad that the quality is degraded and it's no longer relevant, right? So we need to look for any approach to cheat this sort of latency as much as we can. And the way that we do this is we speculate about tool calls, right? So when we get a prompt, when we execute a prompt, that toolbox can have like, you call this, and if you see like this keyword or this property of the request that you're receiving, you might want to start executing those tools before that you've been told to. So basically, we get one request in, and our framework basically fans out, and we'll run 4 prompts at once, taking the parameters from the initial request and sort of reusing them in these leaf nodes like speculative tool calls. And this means when the prompt actually decides that it does want to do a tool call, as you can see in this sort of like next session here, we have this like result cached, and it means that we're reducing the length of the trace, and the trace is less complicated, and we're front loading as much of the work as possible. And like to achieve this, some of these tool calls are like do mutation, right? So some of them might like change the name of an incident. It might create some like resource somewhere that has like a property, right? And we want to make sure that mutation only occurs when we're sure that mutation should occur. So using like SourceGraph's conc library, if anyone's ever used that, it's a great concurrency library that we're huge fans of at Incident. We implement like what's called a write barrier. So as our tool executes, it might execute the prompts up front, and then when it gets to the point where it has the results of those things and it's been told to do a mutation, we implement a write barrier, which basically is like stop there before you're about to make this mutation to the incident data, and then only do this execution if you are told by another prompt to do this. And when you do that, only do it once. And like we basically use those concurrency primitives to sort of make the trace much like skinnier than it was previously. And like this has like real latency savings in production. Like we're really proud of what we built here. It made the quality of the response and the experience like a lot better for internal users. And the reason we can build that is because we're working in a language that's great for concurrency. Cool. So has anyone got any questions? Sure.
Sounds like you've kind of implemented an MCP server.
Yeah. Well, so there are elements of the MCP server. Like, could we connect the foundations we have to the MCP API and like have an MCP server? The answer to that is yes, but it's not. It speaks the same. I think MCP is actually interesting, right? Because it is like another way to sort of frame the nouns that are involved in AI things, just in a different way that's consumable through a well-known interface. And the answer to that is some of the stuff is kind of like that, some of the stuff's not kind of like that. But the answer to it is kind of. If you're used to the sort of like MCP paradigm, a lot of this stuff is like very like that. Yes. Yes.
One more question?
Just wondering if you're using a locally hosted model or the.
So the answer to that is most of the time we're using like cloud models, but we are like pretty model agnostic. And like there's another version of this talk which is probably more interesting, which talks about like the eval suite that we built to sort of test models. Like we can interchange, like so see the model parameter there. You can set something on a context, and you can override the model that the prompt will be run with and stuff like that. So like the answer is we're trying to build this whole thing to be model agnostic. Like there's a lot of stuff that's spoken about like which model is better for what, and the answer to this is we've only found out by just banging our heads off it forever. So for example, like GPT 4.1 came out last night. We've tried it on some of our code change evals this morning, and we're like really excited by how good it is at code change stuff. Yeah.
I'm also wondering if you are keeping trace of the random seed.
Yeah. So like every single request that we make to a foundation model provider, we like codify the response and store it, and can sort of like monitor the performance of it further down the line. Cool.
Thank you. Maybe do the questions during the break?
Yeah, sure. Yeah, I come.
So, yeah, come in person during the break.
Yeah.
Thank you.